Hello everyone, this is Mike Grady from NovaStar. Today I will work with my colleague Gilbert give you this training. Firstly, welcome to NovaStar webinar. Before we get started, please pay attention to the notice. Firstly, please send me your name and email address and company to get today's PPT, and we will email the notice for future topics and schedule. Secondly, for better effect, it is better to mute your microphone. And feel free to text your question in chat window by follow the format for Q1, Q2, and Q3, and my colleague will answer your question in the QA sessions. If you still have some question which is not related to the low latency solution, you can email us and we can just to answer you separately in order to have an efficient webinar training. Okay, then let's get started. Let's invite my colleague Gilbert to give you the today's training, low latency. Okay, Gilbert, please.
Okay, so hello everyone. This is Gilbert from NovaStar. Can you guys hear me? Okay, good. So today I would like to share about our low latency solution. So for the low latency before we go through more details about the low latency solution, I'd like to share two cases about the problems that caused by the latency. So first of all, it's about the TV broadcasts, like the sports games. We watch a lot of sports games, but when we watch those sports games, there are always someone near us making the chair in at once, which makes you feel slower than the others. And the second one is about a conference room application. So from the picture, we can see the spokesperson is raising her hand now, but it's not shows on an LED screen. So the LED screen display is slower than the actual is. It's not a good experience for the people in the room to attend this conference. So from those two cases, we can see there was some latency, there was some delay happens during the video transmission. But what caused the latency? Why there are latency happens? So from the standard LED control system, the whole system structure should be the video source going to sending card, and the sending card transmit the data to the receiving card, and then go to the LED modules. Finally, we can get the video source or our LED screen. So every step of the whole process needs some types to process the data, like doing the decoding, encoding, and transmitting. So they need some time to do the data processing. So those time are latency. So let's take a look about the standard sending card system latency. For the standard sending card system latency, the sending card will cause 1 frame delay. And for the receiving card, it will cause 2 frames delay. And for the drive chips, it depends on what kind of drive IC do you use. If you use PWM IC, they will cause 1 frame delay. If you just use the common drive chips, there is no delay. So for the standard sending card system, the total latency time would be 3 to 4 frames. I know a lot of you guys may use our all-in-one controller. So what about the latency for the all-in-one controller system? So for the all-in-one controller system, because for the all-in-one, we just combine the sending card function and the video processor function together. So compare with the sending card, all-in-one controller itself will cause 2 frames delay. And for the receiving card and drive chips, there is no change. For the receiving card, still 2 frames. And from drive IC, it still need to know what kind of drive IC do you use. So for the all-in-one standard all-in-one controller system, the total latency would be 4 to 5 frames. And someone may ask, what the exact latency for one frame, how long one frame is. For the 60 Hz frame rate video source, one frame is about 16.67 milliseconds. And according to the research, our human eyes can sense 30 milliseconds delay. So no matter you use the sending card system or all-in-one controller system, the latency are all much higher than 30 milliseconds. So which means our human eyes can see the latency on an LED screen. So for the latency problems on an LED screen, what can we do? Actually, NovaStar worked out the low latency solution to help to improve the latency, to solve the problems. So for the standard sending card, for the sending card system low latency solution, for the sending cards, we have MCDRL 660 Pro and MCDRL 4K. Those two products can support low latency features. And for the receiving card, we need to use our high-end receiving card, Armor Series 8S and 810S Plus. And the system structure just same as the standard sending card system. It's sending card, go to receiving card, and then go to an LED screen. But how much we can improve the latency? What the latency we can reduce to? Here's a chart shows more details about the latency improvement. But before we check the details here, I would like to clear one thing. It's about the low latency. The low latency feature for the sending card and the receiving card are independent of each other, which means you can only enable the low latency feature for the sending card or just for receiving card. But what we recommended is enable both sending card and the receiving card low latency mode to get better experience. So as we already know, for the standard sending card system, sending card is 1 frame delay, receiving card is 2 frames, plus the latency of the drive chips, the total latency is 3 to 4 frames. But what about we enable the low latency for the sending card? If we enable the low latency feature for the sending card latency will be changed to less than 1 millisecond. So it's about 1 frame latency improvement. And when we enable the low latency feature from the receiving card, and the receiving card latency will be changed from 2 frames to 1 frames. So there are also 1 frame improvement. So when we enable both sending card and the receiving card low latency, the sending card latency will be less than 1 millisecond, and the receiving card is just 1 frame. And plus the drive IC latency, the total latency from the is 1 to 2 frame. So there were 2 frame improvement when we use the low latency solution compared with the standard sending card system. So this is about the latency improvement for the sending card system. And for the all-in-one controller system, we got Pro UHD Junior, which can support low latency. And for the receiving card, we still need to use 8S and 810S Plus. And what the latency improvement for the all-in-one controller system? We got another chart here. For the standard all-in-one controller system, we just mentioned before, the total latency will be 4 to 5 frames. And when we enable the low latency feature from the all-in-one controller, and the all-in-one controller latency will be changed to close to 1 frame. A little bit higher than 1 frame, but we can just take it as 1 frame. It's very close to 1 frame. And from the receiving card, when we enable low latency, it also will change from 2 frames to 1 frame delay. So when we enable both all-in-one controller low latency and the receiving card low latency feature, the total latency from the low latency system will be 2 to 3 frames. one frame from all-in-one controller, one frame from receiving card, and the other frame latency is from drive chips. It depends what kind of drive IC do you use. So this is about our low latency solution for both sending card system and all-in-one controller system. Because we just go through the low latency solution, we already know what kind of hardware we need to use and what the latency can improvement. So is there anything we need to pay attention to when we use the low latency solution? The answer is yes. There were some of the preconditions of the low latency system. The first one is about the gene lock. We need to disable the gene lock because when the sending card receives the sending card, if we enable the gene lock, the sending card need to wait the VS signal from the gene lock generator. So it takes some time, which means you cannot do the image processing and sending in real time. That makes the low latency impossible. And the second one is about the mirror feature. The mirror feature is a useful feature from the 660 Pro, which can help to get the creative images. But when we enable the mirror feature, the sending card need to get the entire frame data first. If not, there was something happens on the image position, which means there was it will be cause some problems on your LED screen. So we need to disable the mirror feature when we use the low latency. And the third one is about the source. We cannot use the SDI interlane signal because the sending card received the interlane signal. The first thing the sending card need to do is do the interlancing. The interlancing is an option that need to take some time to do the video source merge and the process. So that makes the low latency or just in real time image output impossible. And the last one, preconditions, is about the Ethernet port output. It has to be vertical. In the past, when the Ethernet port output, there was a 1 frame time buffer. So which means no matter how you connected your panels, how you do the screen connections, the Ethernet port has enough time to output the image. But when we enable the low latency, the time buffer will be changed to just 10 rows. That time is much less than 1 frame. So, and also more than 512 pixels in the horizontal direction will cause a significant delay. So we need to do the vertical connection to minimize the weights of ports. Maybe that part is a little bit confusing, but just keep in mind, no matter how we do the screen connections, for each port output, the maximum weight is 512 pixels. Make sure the weights of the port not exceed 512 pixels. So that's all for preconditions for the low latency system. Next, it's about how to enable the low latency. Because the low latency feature default status is off because we do not want the standard products lose the flexibility. So for the senders, if you want to enable the low latency, you need to go to Nova LCD software, logged into the LCD software, and go to settings. There is an option called adjust screen effect. And you can see from this picture, there is a function called enable sending card low latency. We just need to check this box to enable the low latency for the sending cards. And for Pro UHD Junior and 660 Pro, you can also enable the low latency on front panel. There is an option under the function list called low latency. You just enable it. So this is about the senders, how we apply it, how we enable low latency features. And For the receiving cards, A8S and A10S, we still need to go to Nova LCD software and just go to the same page as the sending card low latency enable. There was another option called enable receiving card low latency. Just check the box to enable the low latency for the receiving card, just side by the enable sending card low latency. So this is about how to enable the low latency, how to apply the low latency function to our system. So here we do a summary because we already go through the latency, what caused the latency, and also what NovaStar low latency solution. The third one is we go through the preconditions for the low latency system. And last, we just go through how to enable the low latency, how to apply it to our system. So that's pretty much about our low latency solution. With NovaStar low latency solution, you can get best experience from the live show. So this is about the presentation of today's WebDev training. Next part is about Q&A. If you have any questions, you can put it to chat window. My colleague Alan will help you to answer the questions one by one.